All right, ladies and gentlemen, in this video, I'm going to show you how to find the probability of independent events. But before we do, the first thing you need to know is what is an independent event? An independent event is when the outcome of the first event does not influence the second event. Now, it says, how do you find the probability of two independent events? We're going to end up multiplying the first event by the second event. So I just want to take a quick moment to talk about some different scenarios of what an independent event is. Let's say we were going to roll a die twice. Rolling the die the first time has no influence or no effect on what's going to happen when we roll the second dice. Let's say we're flipping a coin. Flipping a coin the first time is not going to have an effect on when we flip a coin a second time. An example of something that is not an independent event would be drawing a name out of a hat, not putting it back in, and drawing another name. That ends up affecting the chances of us drawing names the second time. So with independent, the first event always is the same as the second event. Okay, so meaning like it's not going to have an effect on one another. So let's take a look at this first example. It says, what is the probability of tossing a coin on tails and rolling a 6 on a die? This is considered an independent event because tossing a coin is not going to have any effect on what happens when we roll a die. So let's think about this. So with probability, we usually see it represented with a capital P, and then in parentheses, it'll tell you the probability of what it is we're trying to find. So in this particular case, we're trying to find the probability of tossing a tails and then rolling a 6. So the probability of tossing a tails, there's only one tails out of the two sides of a coin. So the probability of getting tails is 1 out of 2 times, and the probability of rolling a 6, there's only one 6 on a die out of 6 possible faces. So now all we have to do is multiply these two fractions together. So I look to see if I can simplify anywhere, any numerator or denominator combination. I can't, so I'm going to multiply across. 1 times 1 is 1, and 2 times 6 is 12. So the probability of tossing a coin and it landing on tails and then rolling a die and it landing on the number 6 would be a 1 out of 12 chance. Let's take a look at the other examples down below. Let's say we were to toss 2 dice. So the probability of rolling a 1 and then a 6. So the probability of rolling a 1, there's only one side on a die that has 1 out of 6 possible choices. And if we were to roll the die again, there's only one side that has a 6 out of 6 possible faces. So now all I have to do is check for any simplifying and then multiply across. 1 times 1 is 1, and 6 times 6 is 36. So I have a 1 in 36 chance of this scenario happening. Let's look at the next one, the probability of rolling an even number followed by an odd number. So when I think about a die, I'm going to write all of them here. Even numbers would be 2, 4, and 6. So there are a total of 3 faces out of 6 faces that are even. And the same is true for odd, 1, 3, and 5. So there's 3 faces out of 6. I checked to see if I can simplify anywhere, and I know the 3 6s all simplified to 1/2. So I'm just going to go ahead and cross those out and make them 1/2. And then I end up with 1 times 1, which is 1, and 2 times 2, which is 4. Looking at this next problem here, I have the probability of not rolling a 6, followed by the probability of rolling a 3. So the amount of numbers that are not 6 would be 1, 2, 3, 4, and 5. So that's 5 faces out of 6. And the probability of just rolling a 3, there's only one 3 out of 6, so 1 out of 6. When I look for ways to simplify, I don't see any. 5 times 1 is 5, and 6 times 6 is 36. For this last question, it says the probability of rolling a number greater than 3, so that would be 4, 5, and 6, so that's 3 out of 6. And the probability of rolling a 1, there's only 1 out of the possible 6. Looking for ways to simplify, I know the 3 and the 6 can to 1/2. 1 times 1 is 1, and 6 times 2 is 12. So we have a 1 in 12 chance. So that is how we find the probability of independent events. Remember, the first event does not have any effect on what happens with the second event.